Hi, this is Jason Molesky. In this example, we'll take a look at working with the normal probability distribution. The heights of young women closely follow the normal distribution with a mean of 64 inches and standard deviation of 2.7 inches. Suppose we choose one young woman at random. Let's call her height y. Y is a random variable. And if we repeat the random choice very many times, that distribution of values of y is the same normal distribution that describes the heights of all young women. So for this problem, let's find the probability that the chosen woman is between 68 and 70 inches tall. Well, step one is to state our distribution and values of interest. As we said, the height y of a randomly chosen young woman has the normal distribution with mean 64 and standard deviation 2.7 inches, and we want to find the probability that that randomly chosen woman is between 68 and 70 inches tall. It helps to sketch the situation here so we can draw a normal distribution centered at 64 and shade our area of interest between 68 and 70. Next, we'll perform our calculations, being sure to show our work. So as you recall from an earlier chapter, what we'll need to do is standardize the scores for those two boundary values. We find that the boundary value 68 is 1.48 standard deviations above the mean, while the boundary value of 70 is 2.22 standard deviations above the mean. Now we want the area in between, so what we'll have to do is refer to the standard normal table. Looking up z equals 2.22 in the table, we get 0.9868. And looking up z equals 1.48 in the table, we get 0.9306. Now these are the areas to the left of these boundary values, so to find the area in between, we simply subtract 0.9868 minus 0.9306, and we get 0.0562. So to answer the original problem, there's about a 5.62% chance that the randomly chosen woman would be between 68 and 70 inches tall. For some additional practice, try exercise 23.